All right, good morning, grade 7. We're starting a new unit, chapter 11, on probability. Probability is probably the unit you often don't get to in school, or it's the unit you get to close to the end of the year. It's actually one of my favorite math units. I love it. There's so many fun things you can do with it and different things you can calculate. So I hope that you enjoy this unit as much as I do. It's a little bit of a different concept to think about compared to what we typically use in math. I am going to allow you to use your calculators for this unit because I really want you to focus on figuring out what you need to calculate, and then we're going to spend less time on doing the actual calculations. So you might find some are easy to do in your head, but you might also find that you want to use a calculator for your calculations, and that's totally fine. So what is probability? Probability is the study of how likely an event is to occur. So for example, we could say that it's a high probability that next year Mr. Grin and Miss Krult will be your teachers. That's highly probable because most of you will be coming back to Heritage and they are the grade 8 teachers, and I don't see that changing. I would say it's a low probability that we will have snow in July. That's a low probability, but it could still happen. Okay, so it's the study of how likely it is that an event is going to occur. So maybe Miss Krult decides for some reason to leave Heritage and move to New Zealand, but probably not. So it's highly likely that she'll be one of your teachers next year. Yes, we know God controls and orders all things. It's definitely possible for him to give us snow in July, but it's a very low probability based on what scientists predict and the weather. So if we were in class, I would have you come up with some other ideas of things that are high and low probability. So maybe it's good for you to think about that yourself. If something's high probability or a low probability. The other thing we want to talk about when we talk about probability is possible outcomes. What are my possible outcomes when I flip a coin? Well, if I were to flip a coin, it's possible that it lands on heads, or it's possible that it lands on tails. So I have two possible outcomes when I flip a coin. Now, I'm sure some of you, I can just hear your voices saying, but Ms. Nyhoff, what if the coin lands on its side? Now that I would call a very low probability. It could happen, but for the sake of when we talk about probability in this unit, we're going to assume that your coin does not land on its side. Now, if we take a look at a 6-sided dice, we have 6 possible outcomes. 1, 2, 3, 4, 5, and 6. Okay, and then they each have an equal chance of showing up. So if you're playing a game like Trouble, I think you usually have to roll a 5 or a 6 to get out. You would talk about the outcome 5. Let's say it's 5. That's the outcome you want, but these are all the possible outcomes that there could be when you're playing on Trouble with a dice. Okay, so possible outcomes. What could possibly happen if I flip a coin, or what could possibly happen if I roll a dice? Now, let's talk about if I were to combine those things. So let's say that I want to talk about flipping a coin and then rolling a dice as a combined thing that's going to be happening. What are my possible outcomes? Well, I could flip a coin and land on heads, and then roll a dice and land on 1. I could land on heads, land on 2. I could land on tails, land on 6. So what I can do is I can start listing all the different possible combinations of outcomes if I were to do these two things together. Now, this is a fairly simple setup, but what I want to show you is I want to show you a tree diagram that helps us organize our possible outcomes. So here we have the coin. We have what happens if it lands on heads, and then what happens if it lands on tails. So we could say it landed on heads, and then I rolled the dice, and it landed on 1. Here's my outcome. Heads, 1. Then I could say it landed on heads, it landed on number 2, heads, 2. And then it goes on, all the different outcomes with heads, and then all the different outcomes with tails. So you can see it going step by step by step. So if I take a look here, I can count up all my outcomes. I notice that there's 6 that have heads and there's 6 that have tails. So in total, there are 12 different outcomes or combinations when I'm flipping a coin and rolling a dice. Okay, so this is using a tree diagram. You can kind of think of this as having all the different branches going out. So that's one way to do it in organized ways to calculate all your different outcomes. The other thing that we often talk about in probability is your sample space. So here's our sample space. So on the top we have the dice. Our possible outcomes are 1, 2, 3, 4, 5, 6. And then we have the coins. Our possible outcomes are heads or tails. And then we simply join up. So we have heads 1, heads 2, heads 3, and so on. Then we can count up all the different outcomes in our sample space. And once again, we notice there are 12 different outcomes. Okay. Now you might be thinking, Ms. Naif, like, who cares? Why do I ever need to flip a coin or roll a dice together? It's true. It's not likely often that you need to do that, but it's the most basic way to start understanding probability. Now let's take a look at it in a little bit more of a practical situation. Sorry, my picture's a little bit grainy, but pretend you're at an ice cream shop and you are deciding to have a sundae. Maybe you're along with your little sister or little brother and they're taking forever to decide, and you say, just hurry up and decide. These are your choices. So if we take a look, we have 3 different choices for the flavors of our ice cream. Then you have 2 different choices for your sauce. And then finally, your toppings are cherries or nuts. So perhaps you say to your little sister, hurry up, there can't be that many possible choices. But if we want, what we can do is we can create a tree diagram to actually show them how many possible choices there are. So I start with chocolate as my ice cream. And then they've already filled in part of this for us. Caramel is our possible sauce. And then I'm going to do hot fudge is our possible topping. So I could do chocolate, hot fudge, and then cherries, chocolate, hot fudge, and then nuts, chocolate, caramel, cherries, chocolate, caramel, nuts. And then I can keep filling in this diagram here, okay? And let's see, hot fudge, caramel, cherries, nuts, cherries, nuts. And I can see all the different outcomes are listed here. So I can see them going in a line. So you could say to your sister or to your little brother, okay, look at here are all your different options. Now, if you look carefully, you know it's a little bit hard to see. You should be able to calculate how many options there are. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are actually 12 different options that your brother or sister has to pick in order to create their sundae. So there actually are quite a few different options, because if you change even just one thing, for example, if you have chocolate hot fudge cherries and then you change to chocolate hot fudge nuts, that's a different outcome than chocolate hot fudge and cherries. Okay. All right, let's take a look at filling in a sample space. So here would be a sample space for the same problem that we used for the tree diagram. I want you to be able to know how to use both of these, but you might find that you prefer one over the other. So let's say I have chocolate hot fudge cherries. This is my chocolate column. Now I'm going to have chocolate, caramel, cherries. Now I'm going to have chocolate, hot fudge. I think it was it nuts was my options? Nuts, and then chocolate, caramel, nuts. So you can keep going and fill this sample space in a logical order. Maybe I want to stick with the hot fudge nuts, vanilla, caramel, nuts, vanilla, caramel, cherries. So you can keep going, and then you'll notice at the end, once again, we have 12 different outcomes because each box is a different outcome. Okay? Now, you're thinking to yourself, perhaps, well, Ms. Naif, that works pretty well for something like this because I only have a certain amount of options and I can make a tree diagram or I can make a sample space. But what if I went to an ice cream store and let's pretend that you had 20 different ice cream flavors. Then there were 6 different sauce types. And then maybe you're at a place like, I think it's called Marble Slab, and there are actually 25 different topping options. Can you imagine making a sample space or a tree diagram with that? It would take you absolutely forever. Because if you think about even just doing your 20 different flavors for ice cream, it would be extremely complicated. And then from each line from your 20 different flavors, you would need 6 different flavors from sauces. And then each of those sauces for each type of flavor would need another 25 lines for the different toppings. So fortunately, there's a mathematical principle that makes things a lot easier on us. And that's called the fundamental counting principle. So basically this fundamental counting principle, it's a mathematical statement that does the same thing as your tree diagram and your sample space. Now, I still want you to know how to use a tree diagram or a sample space, but you're going to find that this counting principle is going to make your life a lot easier in this probability unit. So what does it say? It says the total number of possible outcomes, that's what we've been trying to find anyways, is the product, let's remind ourselves that product means to multiply, of the number of items in each category. So if we think way back to the beginning of our lesson, where we had a coin, which had 2 outcomes, and then we had a dice, which had 6 outcomes, the fundamental counting principle says the total number of possible outcomes is the product of the number of items in each category. So my coin has heads and tails in its category. Okay, of the coin, there's 2 items. And then my dice has 6 items in the category of dice. So to find the total number of possible outcomes, I actually just do 2 times 6 equals 12. Which we go back to here, that does match what we figured out on our tree diagram. So we multiply, there's 2 options with coins, there's 6 options with our dice, 2 times 6 is 12. Let's take a look at that when we look at our ice cream. So we had the flavors. We had 3 flavors of ice cream, 2 flavors of sauce, and then 2 toppings. 3 times 2 is 6 times 2, and I get 12 different options for my sundae, which matched up with what we had over here. So the fundamental counting principle is a very quick way to figure out how many different possible outcomes or combinations there can be. So let's try and apply that to this situation. Let's say we spin a spinner, we roll a dice, and we flip a coin. We do all 3 of those things, and I want to know how many different outcomes there could be. So yes, I can create a tree diagram and I can create a sample space, but let's apply the fundamental counting principle. So let's say my spinner, it looks like there's 4 outcomes here. My dice has 6 outcomes, and my coin has 2. So all I need to do is multiply those outcomes. 4 times 6 is 24, and 24 times 2 equals 48 possible outcomes. Okay? Again, you can make a tree diagram, but I think you'll agree with me that this is much faster. Let's try another one. Let's do this. The game Sims. This was a game growing up. I kind of remember playing it in junior high, but you basically had all these different people that you could create in your little town. So let's take a look at the information we have here. You can create people. You have 2 different genders, boys and girls. There's 3 skin tones, and then there's 4 different hair colors. How many different types of people can I create? Well, here are my options. 2 times 3 times 4. 2 times 3 is 6, like this. 6 times 4 is 24. I can create 24 different kinds of people according to the fundamental counting principle. All right, let's do one more. Let's do this. Let's say I need to make a business card to tell people that I work at Heritage, and I have some choices. So I could choose from 5 different colors of paper, 3 colors of ink, and then 2 types of paper, the paper texture, whether I want it to be thick or thin. So my options are 5 kinds of paper times 3 colors of ink times 2 paper textures. 5 times 3 is 15. 15 times 2 is 30. There are 30 possible outcomes for me to create my business card from. Because remember, as soon as you change one thing, you've created a different type of business card. So that's our first lesson on probability. The main thing is to understand that fundamental counting principle. When you do your assignment, grade 7, work very carefully. Sometimes you'll need to figure out, well, how many items are in that set? So let's say it's working with a question with the alphabet. You need to think, well, how many letters are in the alphabet? Or maybe you have to pull letters out of a bag and they tell you that one bag has the vowels and then one bag has numbers 1 through 10. Well, you need to think, well, there's 5 vowels and then there's numbers 1 through 10. So I would do 5 times 10 and I would get 50 different outcomes. Okay? Feel free to give me a call if you have any questions. Remember, grade 7, this is the beginning of a unit. I think a lot of you realized on the test yesterday that you probably should have asked me for help sooner than you did. So if you do poorly on a daily quiz and you don't understand what you did wrong, it's your responsibility to ask me so that I can help you understand it. I hope you have a great day.